Hi, I'm going to talk a little bit about the code health metric and the reasoning behind it and why it's important. The whole idea with the code health metric is to be able to identify code that's hard to understand and hard to maintain. So let's dive right in and look at a code example. Look at this code and assume that we are about to do a change to it. Add a feature, fix a bug, something like that, on a line inside this code. What would that mean? Well, as it turns out, due to how this code is structured, there are several things we have to keep in the back of our head while doing that change. If not, we will probably introduce a bug. And the reason we have to keep several things in the back of our head is due to how this code is structured. So, could this code be written in a simpler fashion? Let's look a little bit closer at it. This is a case statement where the action taken on each case is in line in the same piece of code. And almost always when trying to simplify some code, first thing you could do is to identify chunks of code that you could extract and give a name. In this case, the action taken in each case could probably be extracted into functions with a reasonable name, enabling you to do changes localized into a smaller function and having a much smaller context that we need to keep in the back of our head while doing changes. So that's really the essence of the code health scoring, is to identify complex code like this. And to do that, we have several detectors to find different code smells that drive complexity. You may have heard about something called cyclomatic complexity. That's one of them. Would that by itself be enough? Well, let's look at an example. If you look at this, the code on the right, most people will argue that that's harder to understand than the code on the left. At least you have to think a little bit to figure out what's going on. Yet, if we score that based on cyclomatic complexity alone, they have the same complexity. So it's clear that cyclomatic complexity doesn't quite cut it. So that's why the code health scoring mechanism combines several detectors. In this case, there's a detector called deep nested complexity, which would score lower for the code on the right, because you have for statements, if statement inside one another, making that much more complex. And if you would look at that code on the right and try to make it simpler, well, it's really a variation of the same thing we looked at before. Extract something, give it a name, and make it possible to do changes in a much more localized context. Let's look at another example of a code smell. This is something we call bumpy road. And in this case, the exact details of the code isn't that important, but if you look at it a bit, you'll notice that the outline follows this back and forth structure, similar to a bumpy road, where each bump is really an instance of nested logic. And the problem with that is what happens inside one bump is really very dependent on what happened in the previous one. So complexity really multiplies here. So that's why the code health scoring mechanism has a separate detector for identifying constructs like this and make that part of the code health scoring. As the last example of code smells we look at, let's look at something called low cohesion. And this is a slightly higher level issue. It's not on a single function level, it's class file level. And what that detector is doing is group functions into groups based on what data they access and what other functions they call. And if several such groups that are independent could be identified, that's really a sign of that this class has several totally unrelated responsibilities. And that's really what low cohesion means, something having several responsibilities that are unrelated. And if we look closer at a more specific example, let's look at abstract entity persister.java here. That's a file with 5,000 plus lines of code, 380 methods. And if you look closer at those and group them based on what they do and what data they access, it turns out that the same kind of refactoring could be applied here, but rather than just extracting functions, in this case, it's really extracting entire classes with separate responsibilities and give them reasonable names based on what they do. And that concludes this really short walkthrough of some of the code smells that make up our code health metric. I hope you found it useful.